Understanding mathematical concepts.
Americans, from prominent politicians to the people next door, expressed their concerns that too few students in their elementary and middle schools are successfully acquiring the mathematical knowledge, the skill, and the confidence they need to use the mathematics they have learned. Moreover, certain segments of the U.S. population are not well represented among those who do succeed in school mathematics. In response to this, adding it up, National Research Council 2001, an influential research review on how students learn mathematics, identifies the following 5 strands of mathematical proficiency as indicators that someone understands and can do mathematics. Through these 5 strands of mathematical proficiency, we would know if students really understand topics in mathematics or not. The 5 strands of mathematical proficiency includes conceptual understanding, procedural fluency, strategic competence, adapted reasoning, and productive disposition. These strands of mathematical proficiency build a picture of a mathematically proficient student, and the term mathematical proficiency is the term used to describe what it means to learn mathematics successfully. Its 5 strands represent different aspects of a complex whole. Thus, they are being intertwined, just like in the figure shown. Let's now look at each of the 5 strands in a bit more detail. Let's start with conceptual understanding, which means comprehension of mathematical concepts, operations, and relations. So, for example, students define mathematical concepts in their own words without changing the meaning. So, students with conceptual understanding understand why a mathematical idea is important and the kinds of context in which it is useful. They have organized their knowledge into a coherent whole, which enables them to learn new ideas by connecting those ideas to what they already know. Next is procedural fluency, which refers to skills in carrying out procedures flexibly, accurately, efficiently, and appropriately. When we say flexibly, it means knowing more than one approach, choosing an appropriate strategy, and using one method to double check. Accurately means reliably producing the correct answer, and efficiently means carrying out procedures easily, keeping track of sub-problems, and making use of intermediate results to solve a problem. An example of procedural fluency is students performs mathematical procedures or steps correctly using parallel examples. We have to remember that when students practice procedures they don't understand, there's a danger they will practice incorrect procedures, resulting in them failing to produce a correct answer to a problem. Thus, the first strand, which is conceptual understanding, is needed so that procedural fluency, which is the second strand, will be developed. Let's now move on to the third strand, which is strategic competence. When faced with a mathematical problem, students who are strategically competent have the ability to formulate mathematical problems where they identify accessible questions, make simplifying assumptions, and identify significant variables and generate relationships between them. Ability to represent the situation mathematically, selecting appropriate mathematical concepts and procedures, and the ability to solve mathematical problems, which means they can monitor progress in a solution approach, changing direction as needed, interpret and evaluate results in the context of the problem, and Explain why a conclusion does or doesn't make sense. An example of strategic competence is students translate mathematical problems into mathematical statements using symbols and notations and solve the problem successfully. Strategic competence depends on conceptual understanding, the first strand, and the procedural fluency, which is the second strand. You cannot solve a problem if you don't understand and know the steps or procedures on how to solve them. Furthermore, as students use strategic competence to choose effective procedures in solving a problem, they develop procedural fluency. Aside from that, strategic competence also provides a context for developing conceptual understanding. Therefore, there is a mutually supportive relationship between strategic competence and both conceptual understanding and procedural fluency. Fourth strand is adaptive reasoning, which means the capacity for logical thought, reflection, explanation, and justification. In mathematics, adaptive reasoning guides learning as students navigate through facts, procedures, concepts, and solution methods to see if they fit together in a way that makes sense. Example, students are able to discuss a solution and answer what if questions. Next, as the other strands develop, so does productive disposition, the fifth strand. Productive disposition refers to the habitual inclination to see mathematics as sensible, useful, and worthwhile, coupled with a belief in diligence and one's own efficacy. For example, students see the usefulness of mathematical concepts in real-life situations or in other disciplines. Students who have developed this last strand are confident in their knowledge and ability. Thus, productive disposition towards mathematics is a major factor in determining the educational success of the learners. And that's all for understanding mathematical concepts, and I hope that you learned something from it. Thank you.